hypothesis test, sigma known, number 3. Instructions. This video is a bit different. Here I will present the information, and you may feel free to pause the video and perform all computations yourself to get you some experience using your calculators. Example. 5 years ago, the average math SAT score for students at one school was 475. A teacher wants to perform a hypothesis test to determine whether the mean math SAT score of students at the school has changed. The mean math SAT score for a random sample of 40 students from this school is 469, and the population standard deviation is 73. Do the data provide sufficient evidence to conclude that the mean SAT score for students at the school has changed using a significant level of 10%? Step number 1, as always, let's state the null and the alternative hypothesis. So again, let's just take a look at this last sentence right here. This last sentence states, do the data provide sufficient evidence to conclude that the mean SAT score for students at the school has changed? All right, has changed. So notice that this is a statement of difference. It doesn't state whether it increased or decreased, so we have to take into account that it could be either or. So since this is a statement of change, then we know that this is going to be our alternative hypothesis. So our alternative hypothesis, again, if you want to pause the video, please feel free to pause and state what you think is the null and the alternative hypothesis. The alternative hypothesis is mu does not equal 475, and the null hypothesis is mu equals 475. Step 2, we want to compute the test statistic. So here we have to discern whether we are going to compute the z-test statistic or the t-test statistic. So again, all we have to do is come back to the exercise, and let's just note that the population standard deviation is given. So since the population standard deviation is given, the next step is probably we can conclude that this is going to be a z-test statistic. Again, we have to check for normality and all of that stuff. Normality is not given. But since we have a sample size of 40, we have the central limit theorem that kicks in. So the fact now that the population standard deviation is given, we know that we can use the z-test statistic. So let's just note that the z-test statistic is in the form x bar minus mu under the null hypothesis times the square root of the sample size divided by the population standard deviation. So we know that x bar is going to be 469, that's right there, minus mu under the null hypothesis, which is 475, times root 40 divided by sigma, which is 73. So again, if you want, please pause this video and go ahead and compute this z-test statistic. Here's a hint. Compute this one first, and then hit your division and then go divided by 73. So for the z-test statistic, I came up with negative 0.87. So our next step is to compute the p-value. So let's just recall that to compute the p-value, we need to determine the type of test. The type of test is determined by the alternative hypothesis. In this case, we have the fact that the alternative hypothesis is a not equals. So this is identified as a two-tailed test. So drawing our standard normal distribution, we have here is 0. So here is negative 0.87. And here is positive 0.87. So the p-value then, technically speaking, is right here in these tail areas. So again, this is the p-value. Now, one of the things you can do is you can compute this left-tailed area and then double it to get the upper-tailed area. But using your calculators, we can use the fact that the tail area is 1 minus the middle area. So let's just note that the p-value is going to be 1 minus the normal CDF, which is going to be negative 0.87, comma 0.87. So plugging this into our calculator, we can find that our p-value then, and notice right here, we'll just go 1 minus second distribution, normal distribution, negative 0.87, comma 0.87, and then close that out, press enter, and notice we get 0.3843. So that is our p-value is going to be 0.3843. So that is step 3. So step 4, we have to make a decision. So let's just recall that to make our decision, we have to compare the p-value to the alpha level. So let's just note that the p-value was 0.3843, and right here our significant level is 10% or 0.1, and we can easily see that 0.3843 is greater than 0.01 or 0.1. So that being the case, we know that we will fail to reject the null hypothesis as the p-value 0.3843 is greater than 0.1. So step 5, we want to state the conclusion. So our conclusion then is that alpha equals 0.1. The data indicates that the mean SAT score at the school is 475. Since we fail to reject the null hypothesis, then this means that we're not saying that the null hypothesis is true. We haven't proven it to be true. All we can say with some sort of certainty is that there is not enough evidence in the data to support the alternative hypothesis. This is what our conclusion means when we fail to reject the null hypothesis.